All right, everybody. Today we're going to be taking a look at something called the unit circle. But before we do that, let's do a little warm-up problems in your notebook. So grab your notebook, 5-3 warm-up, and we're going to practice a couple questions that I'm going to be asking here in the near future. Starting sometime in the next few days or a week ahead, I'm going to be giving you a quiz, especially the people who are in school, a quiz each day that is getting the foundational aspects of trigonometry down. And we're going to keep taking the quiz until everybody gets it correct, because we want to make sure that we're doing things really well. So you can have your blue card for now, but eventually when you go to take the quiz, you won't have your blue card. So can you, in your notebook, name the 3 trig functions and which sides they relate? Can you name the 3 reciprocal trig functions and the functions they're related to? And draw and label the 2 reference triangles. So you can pause me here and try to answer those questions, then turn me back on and I'll show you what I'm looking for. All right. The questions got covered up here, but the 3 trig functions. So sine of x is opposite over hypotenuse. Cosine of x, or theta, is adjacent over hypotenuse. And tangent of x is opposite over adjacent. So just writing SOHCAHTOA for me will not count, because I want to see them as equations, and I want to see them written with a variable, either x or theta, inside of there. That's question number 1. Question number 2 is the 3 reciprocal trig functions and the functions they're related to. So cosecant is sine of x, or 1 over sine of x, I should say, the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent's the reciprocal of tangent. This is the answer to question number 2. And then after this, I'll squeeze this down so I can make some room. Draw and label the 2 reference triangles. So 2 right triangles I want to see. I want to see them as 45, 45, 90. 1, 1 square root of 2. And 30, 60, 90. Across from the smallest side, or angle, is the smallest side. Across from the biggest angle, the right angle, is the biggest side. And across from the middle angle is the middle side. Those are the first 3 questions that I'm going to be asking, and those are the answers. That's exactly what I'm looking for. The other things that are going to be on the quiz are what we're about to take a look at today. So, without further ado, let's go the unit circle and quadrantial angles. So title your notebook 5-3 unit circles. Oh, actually, no, you should have a notes worksheet, so you can download the notes worksheet if you're at home, or I might have given it to you the day before if you're at school. And then take the notes along with that sheet. You're going to need your blue card in a minute. We're going to add something to your blue card too. So here we go. So the first thing I want to do is I want to solve for the sine of 150 degrees. So the sine of 150 degrees. Now, if you want to, go ahead real quick on your calculator and type in the sine of 150 degrees. And making sure that you're in degree mode on your calculator. Remember, hit that mode button. You should stay in degrees. It looks like it comes out to be a half, 0.5. Well, why? Why is that the case? Well, to find the exact value of sine of 150, we're first going to draw a 150 degree angle. So all positive angles go up from the positive x-axis, and it's going to stop somewhere in the second quadrant. In fact, it's not somewhere. We know exactly where it's going to be. Because what is the reference angle for 150 degrees? Well, it's 30 degrees. We know that. And then drop a perpendicular down and turn it into a right triangle. And if you look, it's a 30, 60, 90 triangle. 60 up in the corner. So across from the 30, smallest side. Across from the 90, the largest side. Across from the 60, the middle side. But be careful, we're not just drawing the triangle in midair anymore. Now we're drawing it in the second quadrant. Does anything go in the negative direction in the second quadrant? Well, this base, root 3, that's going to the left. That should be a negative. The 1 is going up, so that's going to be a positive. And I'm going to tell you right now, the hypotenuse doesn't have a direction. It's just the length. The hypotenuse is always going to be positive. So now I've got my sides labeled correctly with the correct signs. Now, this is the whole reason why we learn reference angles. We are now going to look from the reference angle, down right there by the origin, and I'm going to then from there determine the sine ratio. So looking from the reference angle, give me the sine ratio. So katoa. Sine is opposite over hypotenuse. So the sine of 150 degrees, it has an opposite side of 1 and a hypotenuse of 2. That's why the sine of 150 is equal to a half. We use the reference triangle in the appropriate quadrant to evaluate the trig function value. Let's try another one. Sine of negative 300. So we draw our triangle in the appropriate quadrant. So negative 300, where does that terminate? So we're now going backwards, negative 90, negative 180, negative 270. So somewhere in the first quadrant is negative 300 degrees. The question is, what's the reference angle? Well, I've come around 300 degrees. I have another 60 to go. So it's a 60-degree reference angle. Across from the 60 is root 3. Across from the 90 is 2. And along the bottom is a 1. Is anything going in the negative direction? Nah. Everything in the first quadrant is positive. Again, hypotenuse always stays positive. So the sine of negative 300 degrees, I will then just look from the reference angle. So looking from that 60-degree angle down there, give me the sine ratio. Opposite over hypotenuse, so square root of 3 over 2. You can check it on your calculator. So it's going to give you a weird decimal if you type in the sine of negative 300. Well, just compare that decimal by typing in the square root of 3 over 2, and they should be the same. We don't want those decimal values because they're not exact. We like these rational expressions written as roots and instead of big long decimals. All right, now it's the cosecant of 135. Okay, you can pause me for a second, maybe write down or sketch the triangle in the appropriate quadrant for cosecant 135. So sketch 135, see if you can figure out its reference angle and label it up. Then we can talk about cosecant. You can pause me to try it on your own first. I'm seeing a 45-degree reference angle. And be careful, the 1 is going to the left, so that's negative. Now, cosecant is the reciprocal of sine, so let's maybe first figure out the sine of 135. So looking from the reference angle again, always looking from that little reference angle, what's the sine ratio? I keep picking sines here for some reason. All right, so opposite over hypotenuse. Oops, that's not right. Not square root of 3, square root of 2. So now I want the cosecant of 135. Well, that's not real hard. You just take the reciprocal. Boom. Done. All right, next kind of a question is find the values of the 6 trig functions with an angle with a point of negative 4, negative 3. This is an easy question. So where is the coordinate negative 4, negative 3? Which quadrant? 1, 2, 3, or 4? Well, you'd be right if you said quadrant 3. So I'm going to the left 4, and then I'm going down 3. So that's this coordinate right here. And we're always going to make triangles up with the x-axis, just like we do with our reference angles. So this side is negative 4. This side is coming down negative 3. Quick little Pythagorean theorem. Or realize that this is a 3, 4, 5 triangle. We've seen that Pythagorean triple a couple times already. Now I want all the 6 trig functions of the actual angle that's coming around, but remember, the angle trig functions can be evaluated by just looking from the reference angle. So let's list out here. We're going to call this sine of x, cosine of x, tangent of x. So look from the reference angle and get your sine, cosine, and tangent values. You can pause me and maybe try to get those and then compare. Sine is negative 3/5, cosine's adjacent over hypotenuse, and then opposite over adjacent, which would reduce to 3/4. So now the other 3 are a piece of cake, because what are we doing? We're just reciprocating them. Done. At this point, we still don't know what the angle is. We're going to save that for a future lesson of trying to figure out what the angle is that I'm involved with. All right. So the next thing that we're going to look at is finally this idea of the unit circle. And this is kind of interesting. So I would like to know what the sine, the cosine, and the tangent of 90 degrees is. Now, if you remember, I had said that we're always going to either look from this angle or this angle. We are never going to look from the 90 degrees. We're never, because if you look from the 90 degrees, across from it, its opposite side is the hypotenuse. So it can't be the hypotenuse and the opposite side at the same time. That doesn't make any sense. If anything, here's a really weird thing, and maybe I'll talk about this at some point, is we're going to let this angle be 90 degrees. Well, if I let that angle be 90 degrees, what's that mean this angle's got to be? Nothing. It's going to be 0 degrees, so we don't even have a triangle anymore. Actually, this could be a method that we could figure out sines and cosines and tangents of 90 degrees, because across from 0 degrees, remember, this isn't even an angle. It's not even opened up at all. Well, if this angle has no measure, then its side opposite has no length. And across from the 90 degrees is this opposite side, and across from the actual 90 degrees of the triangle is the hypotenuse. They have to have the same value, because they're both across from 90-degree angles. So right there, we can also already have a glimpse that if I wanted the sine of 90 degrees, look from this 90 degrees, not the corner one, this 90 degrees, and the sine is going to be opposite over hypotenuse. So it looks like it comes out to be 1. That's interesting. So, and I could do the same for cosine and tangent. I could do all of those types of things. So that's one method to create what I call these fake triangles. So these triangles don't really exist because this has 0 degrees. In fact, if anything, this triangle is just a flat line, because it would be the hypotenuse and the adjacent or opposite side of that 90. They'd be right on top of each other. They have the same length. But there's another way we can explore this. So it's by exploring the unit circle. So what is the unit circle? On your paper, and there should be a spot, there should already be a circle. Got a circle, and I want to label or put the radius in, and the radius is going to be a radius of 1 unit. That's why it's called the unit circle. So radius of 1 unit, which means that all of these points where I hit the x-axis, like I know this coordinate now. If the radius is 1, this is a coordinate 1, 0. Over 1, up none. What's up at 90 degrees? That'll be coordinate, what's the x value? 0 with a radius of 1. So -1, 0. And down at 270, 0, -1. All right. So what's going on? Well, we're going to drop a perpendicular inside my unit circle. So drop a perpendicular down so we can get our right triangle inside the unit circle. But notice that the hypotenuse has to be equal to 1. The hypotenuse has to be equal to 1. So if I just draw another triangle off to the side. So at this point, I'm going to be looking from this little angle down here, and I'm going to call it theta. Typically, this side is opposite, this side is adjacent, and this side is the hypotenuse. But I want the hypotenuse, let me rewrite this over here. I want the hypotenuse to always be 1. So what will I have? The hypotenuse, sometimes it's 2. On the 45, 45, 90, it's a square root of 2. What could I do to always guarantee that the hypotenuse is 1? Well, if I divide it by the hypotenuse. But if I divide one side by the hypotenuse, I got to divide all the sides by the hypotenuse to keep the similar triangle. Well, now I have a hypotenuse that equals 1, but what does the opposite over hypotenuse? What is that? That's actually opposite over hypotenuse. That's the sine function. And adjacent over hypotenuse? Well, that's the cosine function, which means then these two sides of the triangle can be expressed by whatever the sine and the cosine are. So the sine and the cosine, oops, that's not right. That should be cosine along the bottom there. Sorry. So this is cosine, this is sine, theta, and the hypotenuse is 1. That means I've come over in my triangle, I'm going to be coming over the cosine of theta and up the sine of theta, which means that this coordinate, wherever I hit on the unit circle, is always whatever the cosine of the angle is, followed by the sine of the angle. Well, what does that mean? Well, then that means, well, let's find our angle that we just did earlier. Here's 90 degrees up top here. So if 90 degrees is right up top here, it has a coordinate of 0, 1. Well, that means that 0 corresponds to the cosine value. I can now say that the cosine of 90 degrees must be equal to 0. This value of 1, the y value, that must be equivalent to the sine of 90. So I can say the sine of 90 degrees is 1, and that's what we saw earlier in my fake triangle. Any point on the unit circle, I can find its sine and its cosine value. Now, I can even do it for all the angles that fall in between. I don't know, this looks like a 45, 45, 90 degree triangle, but I've got other ways of figuring that out, at least for now. We're going to use this just for these, I call them corner points, but they're the quadrantial angles, the angles at the corners of the quadrants. So this is what we need on our note card. We need this relationship drawn on our note card. So take a minute, maybe pause, and get that onto your note card. And then I've got one more thing to say. So at this point, now we've got sines and cosines. What about tangent? If I go back to my little fake triangle, or not my fake triangle, but my triangle over here down in the corner, let's take the tangent of this angle. What would the tangent of this angle be? SOHCAHTOA, opposite over adjacent. The tangent of any angle is always equal to the sine of the angle divided by the cosine of the angle. So I can even get tangent values off of the unit circle by dividing sine divided by cosine. This is worthy of going on our blue card as well. So pause me and get that on the card too. All right, so now I want to maybe fill out this table here, which is on your card. But I got to get myself my unit circle down here so I can deal with it. So 1, 0, 0, 1, negative 1, 0, 0, negative 1, radius of 1. There is theta, drop a perpendicular, and every coordinate on the unit circle is the cosine of the angle followed by the sine of the angle. All right, here we go. So I'm over here at 0 degrees. 0 degrees is the positive x-axis. The x values are always cosine, so the cosine of 0 degrees looks like it's 1. The sine of 0 degrees must be 0. Tangent, let me get that on my paper here too. You guys already have it on your card. Tangent is always sine divided by cosine. So tangent in this case is the sine, which is 0, divided by the cosine, which is 1, and 0 divided by 1 is 0. Excellent. So now the others are simple. They're just reciprocals. So what's the reciprocal of 0? Well, remember, 0, we just saw it for tangent. 0 written as a fraction is 0 over 1. So the reciprocal is 1 over 0, and try it on your calculator. 1 divided by 0, you can't take something and divide it by nothing. So that is going to be undefined, UND. So again, UND is standing for undefined. We can't define what that equals. No value. Well, that's interesting. So I have some values that don't even have a value. Talk more about that down the road. So that's undefined. What's the reciprocal of 1? Well, 1 over 1 just stays 1. And here, tangent was 0 over 1. So if I flip that upside down, it's going to be 1 over 0. That's undefined. So we've got a bunch of different values that become defined and undefined. So that's interesting. Okay, let's go to 90 degrees. So now I'm up at 90 degrees. Cosine is the x value. Sine is the y value. Tangent is sine over cosine. Oops, looks like we got another undefined. I think that's going to happen quite a bit here. Reciprocal of 1. The reciprocal of 0 for secant. Well, reciprocal of 0 is undefined. That's going to flip upside down. And tangent was 1 over 0, which was undefined, but now if I flip it upside down, it's 0 over 1, which is 0. Let's see maybe some patterns. If you want to pause me, and then go on to 180 degrees and get your cosine and sine values. Lots of undefined values here. 270 is going to be down at the bottom. And the easiest one is 0, y. I'm sorry, 360. Just gave it away. 360 and 0 coterminal. They're going to have the same sine and cosine values. So that one's a piece of cake. So again, we could punch these into our calculator. You could go through with any of these sines, cosines, and tangents, punch them into your calculator. But we want to know where they're coming from. And so we're going to use the unit circle to get those values for us. All right. So now the end here is what we want the cool down. This is on the back of your sheet. So these are the last couple questions that are going to be on the quiz that's going to be coming up. So draw and label the unit circle indicating which trig functions represent points on the circle. How can you determine tangent? And then what's the sine of 60 and the cosine of 180? So take a minute with 4 and 5. You should be able to put those on from your blue card that you just did. And then we can top those. This is what I want to see for your unit circle. All the stuff I want to see. And then question number 5. How is the tangent gotten from the unit circle? Well, tangent equals sine over cosine. So that's the answer to number 5. Then at this point, you have all of this up on the paper and up above. So when I get to questions 6 and 7, these are the questions that might change from day to day. But the purpose is that everything you have written on the paper so far should help you answer questions like, what's the sine of 60? Well, I'll go up to my 30, 60, 90 triangle that I drew earlier, root 3, 2, and 1, and take the sine of 60, opposite over hypotenuse, square root of 3 over 2. Cosine of 180? Well, I don't use a triangle for that. I'm going to go over the unit circle. So where is 180 degrees? Well, that's this coordinate. What is the cosine value? Well, that's always the x-coordinate, so it looks like the cosine of 180 is -1. And there you go. All right, there should be some practice problems on a worksheet coming up. Check my Canvas page, daily page for that. Good luck.